Hi, my name is Kevin Starr, and I work with ABB, and I'm here to talk to you about our digital solutions. We just finished a video that talks about the digital story and how to navigate the digital information and the Industrial Revolution 4.0. This particular video works as itself on balancing the service equation on corrective, preventive, and predictive, because the predictive really touches on the digital components that ABB has to offer. And then after this will be another video that talks about the process that we follow, so that you can see a logical way to navigate this storm and all the noise that's coming at you about what's available, what works. We're going to take it to you from the brass tacks all the way up to cloud computing. In that process, we need to talk about how we balance the service equation. All industrial processes take a raw material and convert it into something. It could be paper, it could be metal, mineral, mining, oil, gas, chemical, this is basically a process transducer. But they all have equipment that is unique to that particular unit or business unit or industry. A paper machine is very different than an offshore oil rig, which is different than a refiner, but they all have equipment that is unique. But then they have automation that governs that. Flow loops, pressure loops, temperatures, alarms, cybersecurity, platforms, those can be very, very common. And so that's why ABB is able to work with all these different industries and help align our solutions to help optimize this conversion process. Because when we do that, it has an impact on production, it has an impact on quality, it has an impact on cost to produce, and it has an impact on the quality of life of the guys doing the work. We want you to be safe, and we want you to be reliable, and we want you to be optimized. And that's what we have here to offer in the digital space. We've learned a lot about service over the years. We've learned a lot about operations. We've learned a lot about production. And that's what I really quickly want to touch on as we go through this. So there's so many areas that we could talk about, but just to sort of break it down is you have a plant, and now it's whatever your plant is. You're watching this, it could be any industry plant. You take actions to try to adjust the value, whether it be increased production, quality, cost to produce, total cost of ownership, in general terms. Now, if we're talking a refiner, I would talk in refiner terms. If we're talking paper, it'd be paper terms. If we're talking metal, but in general, you take actions of some sort on your process, your plant, your business unit to affect value. That's not something that's uncommon. Now, what we do here is you don't just take those actions randomly. There's somebody taking decisions. So usually you have a target. You want to run here. You want this quality. You want this cost. You have a target. And then you have a group. It's morning meetings. You have your managers, your production folks, your corporate, and you have decisions. And you have different indicators that tell you how you're doing based upon your process performance. So you have this circulation of information, and you decide actions to take to your plant so that the indicators allow you to make decisions. So the question is there ever a case where you don't hit it right? And the answer is yes. There are things that can come into your plant that are unknowns. You can get into material issues, mixing issues, people issues, and then there's the electrical and the instrumentation and the control, and maybe there's a cyber threat. There are things that can come in that can cause you to have a loss. And that's where we need to start talking about, is how do we start mitigating the risk of loss? And then when you start minimizing the problem space, then you can maximize the opportunity space. And that's what's fun, is when you can start balancing all this. So we could talk to you about personnel, we could talk to you about equipment and automation, but what we're going to do here is show you how you can take service techniques applied in the automation space to eliminate the need for a failure and a correction. So on the right, what we're seeing is that splat is an incident. Something happened in the problem space that you weren't expecting. Boom, you start losing your production, you start losing your quality, your cost to produce starts going up, and now the clock's ticking. So we have a time element. So we had an incident, and now we have a time element. So the time is how do we get the right answer with the right person at the right time to bring this cost function back into a balanced state. That's what we're trying to do. And what I found, my background is process control. We've done a lot of videos on automation. And when I finally put this together, this looks like a single loop control tuning problem. Once I realized that's a disturbance and we have actions, we can tune this, guys. We can fix it. And that's what we're going to show you, is how do we come up with solutions to mitigate and minimize the risk of lost time. So The problem space, this big black blob, that's that thing that happened. There's a lot of things that can go wrong, but it's not infinite. And if you break it down by an asset or a function, it's even less. So the issue is we've got that's what the jagged window is. It's the problem space for an asset, like a loop or an alarm or an actuator. Think in terms of assets or swim lanes. It can be daunting if you think of everything, but in the automation space, it's either, electrical, it's an instrument, it's an actuation, it's a control loop, it's an alarm, it's cyber, it's safety, it's in those different categories. So now their red dot happens. Something happened right in the middle of the problem space. So how do you identify that? How do you find it? The clock's ticking, you're losing money, so how do you find it? So one of the things that has started with service was corrective action. Is we have to dispatch the right person at the right time with the right solution. And when the problem space was small, we could do that. But now the problem space is growing, it's very difficult to know if you got the right solution or we're solving a symptom. And then the other thing that we're running into is workarounds. You know what I mean by a workaround? It's when the operator realizes that bug or that control, when he turns it on, it oscillates, he just can turn it off. Problem solved. Or he figures out how to get around it. So now we have all these wounded assets that aren't really working, and then that becomes common practice. And then the next service engineer, he sees that that's the way it runs, and next thing you see is automation being turned off. Guys, we never made our automation equipment to be turned off. If it's off, it's broken. If you don't hear anything else in this video, if it has ABB on it and it's off, it's broke, and it needs to be fixed. We did not design our stuff to be turned off. But this is corrective action. So you need to have a mechanism so that you know when you have an incident, how do you get that to the right people? Do you have the phone support, the call center? Do you have the dispatching? Do you know who to call? That type of thing. That has led to another area, which is called preventive maintenance. Preventive maintenance is typically, you can't cover the entire problem space. So that's where we start having physical rounds or checks and measures where we're actually going around and we're checking things. And that's where I have that little picture on the corner there, the rounds. You can see here, this is this guy, he does physical rounds where he touches things. I can remember being in industrial sites where I could actually see the footsteps of the maintenance guys wore out the tiles because they took the same steps or they touched the same actuation devices. You know how many pumps are in? We've got some industrial sites that have 5,000 pumps. You have a guy touch 5,000 pumps, or controllers. When it used to be, when I was doing this 30 years ago, there was maybe 10 or 20 control loops. Now there might be 1,000 or 1,500. We can't do what we used to and expect different results. I was telling a story about a guy that was checking the servers to see, how simple can that be? Check the server to see if it's got a hard drive problem. He went and checked each one, doing a physical round. He checked it all off. He said everything was good, and the system went down. Somebody had turned on a video page. It had unresolved reference. It ate up all the references, and the system died. He's like, I just can't keep up. So physical rounds, so corrective maintenance was the first thing. Then it went to preventive maintenance, which is still needed. We can't solve everything digitally. But don't forget, we have digital solutions now. That's the next generation. That's what's coming, is the digital signatures that is in the information. In my history of 30-some years doing this stuff, when I started is with pneumatics. We had to have pressure to current transducers, snubbers, and all that kind of stuff just to get data. It was an incredible effort just to get data. And then when we got to 4 to 20 milliamp loops and we could put a resistor in the loop and we could do like 15 control loops at one time, we thought that's awesome. Then we went to centralized controllers and then decentralized controllers, and now we have data lakes, and we have more data than we ever had. And we have more problems than we ever had because we still try to do it the way we used to with corrective and preventive. Guys, if you're doing predictive or doing preventive maintenance where physical checks and measures and you have the means to have a digital solution, you really should talk to us about how we can help expand your circle of influence. How can we do digital rounds? How can we have the data come to us? Anytime you have to go someplace, you're already too late. You don't have enough time now. We don't want to add another thing for you to do. We want to reduce the problem space. And that's how I like to look at this. There's been a lot of black eyes on digital. They thought that the digital space would cover the entire problem space. That's just not realistic. There is a space that digital covers. that should be covered. It should reduce or maximize the effort or minimize the effort in finding an incident. And that's how I like to do it. So now if I have a red bleep that goes off, if it's in the digital space, my signature should actually have predicted it, and I could have caught it and made sure I had the right parts. If it wasn't, then I could have probably fixed it through a preventive maintenance, and in worst case, I know who to call, which is the corrective action. So when you balance the scale, you can actually stay on top of the situation. So if you have corrective maintenance, you're looking at response time, call center access, parts availability, skill alignment, incident recognition. Do you actually have that set up? So these are things for you to be thinking about in your assets or functions. We're going to finish this off with the same list, and you say, do I have a corrective maintenance strategy for these assets and functions? You decide. We can help you if you need that. The next one is preventive maintenance. Do you have physical checks? There are things you have to check, cables, wiring, things that you have to do visual inspections. But even today, there's mobility, there's wearables, there's all kinds of things that we can do to reduce the risk to humans and expose or increase the exposure to incidents. So we can have standard operating procedures, work order management, library maintenance, so that we can start correcting our process and improving our preventive maintenance. So we should be balancing corrective actions and preventive actions. So I like to say was when there's been a problem and you had to call me, the next thing I'm going to do is look at your preventive maintenance schedule. Say, okay, well, how did we miss this? Can we augment your preventive maintenance schedule? Do you do that? If not, you need to. And then the last one, which is what the digital space, this is what I'm excited about, is the digital world of automation has grown so much that we can't do what we used to do and expect different results. The number of automation equipment is just so big, and I don't want you to hear that people are stupid. I don't believe that. I just believe that the problem space has grown beyond our ability to handle the entire thing. One person, just look at your car. Years ago, you could actually troubleshoot your car. Now, you got to take it in, have a diagnostic port, and he tells you something to do. Our automation space is going there. That's what's allowing us to get the productions that we've got, the quality that we've got, the cost to produce down. We can't live without automation. I was so fortunate to have some production mill managers work with me that were way ahead of their time using data and data analytics to troubleshoot and remove bottlenecks. So I've gotten a chance to see predictive work, and I've been able to see what the problems with it is false positives. When a digital signature comes through and you think it's broken, but it's not, be careful with that. That's why you still have to maintain your digital assets and your digital predictions. However, when you balance this, you don't need to send a guy to every room to check hard drives. That data should come to him. He should know this hard drive is going bad, so he's not physically checking. He's going with the right problem, with the right solution, with the right package, with the right skill set. That's when you've empowered your employees. That's when you've gotten in charge of your system and your automation, and you can drive towards your production and quality direction and targets that you're after. So this is what I'm talking about, is how do we take your system and how do we break it up into corrective, preventive, and predictive, and how do we do that? And that's what I'm saying here. This is the goal, is to have your process run through this systematic approach to corrective, preventive, and predictive, and dispatch automatically solutions to equipment, actuation, alarms, loops, safety, cyber, and a whole host of other things. When you have that, you know you have the right person at the right time with the right solution. That's the goal. And we can do it with, there's so much you can do with just a phone call. There's so much more you can do with a regular preventive maintenance program on things that need it and where your system's at. But don't forget that the digital signatures that are available can reduce the load on your staff so that you can get on top of your problem and you can fix them and even help with your downtime that's coming up. We see people look at their preventive and predictive signatures and look at when there's going to be a failure. Then when you have your scheduled downtime, you can improve your performance during that downtime of maintenance activities. This is happening. This is the solution. This is what you want. So what I want you to do now is to take a minute and look at your asset and functions. Again, this is the same picture that I had on the same column of IT/OT mobility, cyber safety, alarm loop, all the way up the stack. And ask yourself, do I have a corrective maintenance strategy for that swim lane? Do I have preventive maintenance for that swim lane? And do I have predictive? we can help you move towards the right in the areas that you need to have that. We have global examples, we have expertise in all of these areas, and we can work with your system and we can work with the ones that say ABB. Many of our opportunities for service are vendor neutral. And so we have tons of solutions that can help you reach your production, quality, and cost to produce goals. Plug into ABB, we've got you covered.